Okay, you're now watching video 5E to look at answers to questions 4 to 7. So I'm going to go back to question 4, which really means looking at 3. Okay, so in the video you watched that included this matching exercise, the solution presented relied on looking at individual x and y values, which is fine, but there's a deeper analysis that can be done here and allows you to answer these sort of questions more confidently, I think. So if I just look at A, B, C, D, well, I notice that A, in this one, dy dx equals 0 when x equals 1. And spotting a gradient of 0 is very easy here. So I can see here, okay, through the line x equals 1, we have gradients of 0. And if I look quickly at the rest of them, right, then it's not the case. And so that's all the evidence I need that this is A. All right, so I'll cross that one out. I'd also like to point out that this is not necessary, but with the denominator being squared means the denominator is always positive. So the sign of this depends on the sign of x minus 1. So we have positive here and negative here. Right. Next, I observe that in question 1, the slopes are independent of x. Right, they're the same all the way across, so they're independent of x. And in the equations, the only one that's independent of x is D. All right, there's no x in this one, so that's all the evidence I need to make that conclusion. All right, looking at the next ones, what can I observe? Well, I can observe this, that sticks out to me. And so what I'm observing is that y dash is infinity. I mean, it's really undefined, but when x equals -1, and well, that I can't see a denominator here, so right, so now I'm going to look at this one. Okay, so y dash equals 0 when y equals 0. Okay, so silly me. Now I see, of course, that this is x equals -2, and I have that same thing here. So anyway, property B is here and also in all of these. Okay, so we have B for this one, cross that out, and so this one is C by elimination. But let's have a look at it. So in C, it's xy plus x, which is x lots of y plus 1, right? So this is 0 when x equals 0 or y equals -1. And look at that, when y equals -1, then the y dash is 0, and when x is 0, it's okay. So I've matched all of them looking at more holistic properties of the equations rather than specific points. And if nothing wrong with specific points, and that can be good to check if you've narrowed it down to 2 and you're not sure. But it's good to engage in a bit of deeper analysis of this. And mostly it was by looking at where the slope was horizontal or vertical. Okay. Right, question 5. Well, this is from a NESA paper that we received not very long ago. Okay, which of the following could be the differential equation represented. So we're doing a match here, but it's not matching 4 to 4. It's just, yeah. So what can I observe? Well, it seems pretty obvious from the graph that y dash equals 0 when y equals 0. That's just what seems quite apparent. And so it must be C or D. Okay. And now there's not much difference between those two. It's just one sort of positive-ish and one's negative-ish. So I'm going to try the first quadrant. All right, so that's where x and y are both positive. And these are all negative gradients. And so the only one that works is D. Okay, because positive over 3 is positive, and then you got the negative. Okay, so the answer is D. Now, you could think about it differently, or you could try one, you could try 2, 1. Okay, 2, 1, that's 2 times 1 over negative 2/3, right? There's a gradient of negative 2/3, whereas this would give a gradient of positive 2/3. Sure, you could answer this other ways, but that's how I do it. Right, additional questions that I made up. So, sketch 3 curves through the field. All right, I'll get rid of this. 3 curves through the field. Well, if I just sort of go like this, and I'm trying to sort of stick to channels and definitely not cross. That's an interesting one there. Trying not to cross any so it's probably a bit easier when they're quite dense like this. What if I did this? All right, so obviously I'm going up. Right, so that's going to do something like this. It'll go a lot further down, I would suggest, but then it looks quite symmetrical, so it would come back up here somewhere. Okay. If y dash equals 0, this looks like the equilibrium solution. So there we go. There's 3 curves through the field. Sketch the curve that includes 1, 2. 1, 2. Oh, well, I've sort of accidentally done that already, pretty much. So I'll take that and find its equation. So this is solving a differential equation. We have y dash equals negative xy on 3, and through the point 1, 2. So dy dx is negative xy on 3. I'm going to take 2 steps here. Dy equals negative 1/3 xy dx, and then divide by y. So dy on y equals negative 1/3 x dx. Okay, I'm going to do something that I would never normally do and reuse that line of working. And right, so that is things you do when you don't have much room. Okay, and e to the c is going to be called a. And so there we go, where a is positive, negative, or 0, because that gives us this one here. All right, so that's a bit of a mess. I'm sorry, but we also need to find, we need to include this point. So all right, so we've got y equals a e to the negative 1/6 x squared. All right, and so we have 1, 2. So that's 2 equals a e, and then that's just negative 1/6. So we're going to multiply both sides by e to the 1/6. So a equals 2e to the 1/6. And so y equals 2e to the 1/6 e to the negative 1/6 x squared. That's the answer. Right, you could graph that in a software package and check that it matches the curve we've got there. Right, and next, question 6. Okay, this is from Manessa sample HSC paper. So we were very glad to see what kind of questions would appear in these new topics. Right, we've got an interesting equation here. The slope field is given. Identify any solutions of the form y equals k, where k is a constant. We've answered questions like this before, the constant solution. And we can tell, it stands out in the slope field that y equals 2 is a solution. And we've answered before by looking at, well, if y equals 2, then both sides of this are 0, right? Then the left-hand side is the derivative of 2, which is 0, and the right-hand side is 0 because y minus 2 is 0. All right, this has been covered very well in earlier lessons. So y equals 2 is the answer to this, and we only need to identify it. We don't need to explain anything. And question 2, draw a sketch of the trajectory of a particle that passes through the point -3, 1, and then that's this little point here is given, and describe, okay, come to that. So -3, 1, so something like that. Okay, careful. If I did something like this, then that's wrong. I'm now crossing through all of these things. That's completely wrong. Okay, I very deliberately did that to show you what is not a good answer. Right, there's 3 marks allocated to this. I think this would be 1 mark, so 2 marks for the 2 marks for the sketch. It's not that difficult. Just got to make sure you're careful. Okay, and we're sort of on a nice guided path here where I'm not going through anything. There we are. Okay, and describe the trajectory as x is, right, so as x goes to infinity or to negative infinity, y is clearly going to 2. That, why we call it an equilibrium solution. Okay, and finally, this final question has nothing to do with DEs. It's about function transformations. I think we all would admit that we'd like some practice at that. So here's an exam style question, multiple choice. I think it was the last of the multiple choice questions, so it's pitched as not being very easy. So what pen would you like, ladies? I think I'll go green for this one. So we're starting with y is inverse sine of x minus 4. The first thing we do is dilate horizontally with a scale factor of 2. I suppose I should actually colour code this, shouldn't I? Okay, so dilate horizontally with a scale factor of 2. That means x is replaced with half x. That achieves that horizontal dilation. And so we get y equals inverse sine half x minus 4. All right, so that's step 1. And now step 2, and then translate it to the right by 1. I can't help smugly pointing out that when we were teaching this topic, I drew attention to the sense of this transformation and then that being an extremely important concept. Okay, translated to the right by 1. That means x is replaced with x minus 1. So I get y equals inverse sine of a half x minus 1 minus 4. Okay, and now we need to make it look like one of the options. So this is y equals inverse sine of x minus 1 over 2, and 4 is 8 over 2. So y inverse sine x minus 9 over 2, it's a. Right, now all of this, inverse sine was completely irrelevant, right? We started off with a function of x minus 4, and we went to a function of a half x minus 4, and then we went to a function of a half of x minus 1 minus 4. All right? Okay, that is the end of lesson 5.